These notes are on the relationship between the vertex and x-intercepts for quadratic functions. So let's look at this first example to see if we can sort of get a sense of the relationship between the x-intercepts and the vertex. So we know that the x-intercepts happen when y equals 0. It's along the x-axis. So I can plug in 0. And then I have that two quantities, when multiplied together, equal 0, which must mean that either the first quantity, x minus 5, equals 0, or the second quantity, x plus 7, equals 0. So either x equals 5 or x equals negative 7. So let's plot those 2 points. So positive 5 and negative 7. Now we know that a parabola has a line of symmetry, and we know that any point along the same horizontal line, it has to be halfway between that line of symmetry. So we know the line of symmetry has to be exactly halfway between the point negative 7 comma 0 and the point 5 comma 0. So because I have this graphed anyway, I'm just going to count, this is 5 over, this is 5 over, so then one more over would mean that our line of symmetry is right here, line of symmetry. So now we know that our line of symmetry is x equals negative 1. We also know that our line of symmetry is always going to be, our vertex is always going to be on our line of symmetry. So our vertex is either somewhere up here or somewhere down here. But what that really gives us is it means that our vertex, the x-coordinate of our vertex, we know right now is going to be negative 1. So since we know that x is going to be negative 1 for our vertex, we can plug it in. So I really want to find f of negative 1. So that's negative 1 minus 5 times negative 1 plus 7. It's negative 6 times 6, which is negative 36. So now let's go back and look at some of these numbers a little bit more carefully. So the second part about this is that we plugged in the x-coordinate, the line of symmetry x value, and that gives us the x-coordinate for our vertex. The way we got the line of symmetry was to go halfway between our two x-intercepts. And if we want to talk about halfway in between, one way is to draw, have the graph and draw the number line and be counting over. The other ways, though, is that half is an average. So it turns out that our line of symmetry is going to be our x-intercepts added together, average, divided by 2. That's negative 2 over 2, which is negative 1. So here's a algebraic method, and this is the pictorial method for finding that line of symmetry. Let's look at another example. Sorry about that. There we go. Here, let's look at another example. So in this example, we're asked to find the x-intercepts and the vertex, but I haven't been given a graph. Now, of course, I could graph it if I wanted to, but I am going to want to do this just using my knowledge of the relationships between the vertex and the x-intercepts. So again, I know that my x-intercept happens when y is 0. And I know that in order for these three numbers multiplied together to be 0, one of them has to be 0. Well, 2 is never going to be 0, so I can ignore that. So I have x plus 3 equals 0, or x minus 9 equals 0. So x equals negative 3, or x equals positive 9. So my x-intercepts are negative 3 comma 0 and 9 comma 0. My vertex, the x-coordinate is going to be the average of these two numbers. So negative 3 plus 9 divided by 2, positive 6 divided by 2, 3. So I know that my vertex, my x-coordinate of my vertex is positive 3, and I now need to find my y. And I do that by plugging in 3 in for my x. 2 times the quantity 3 plus 3 times the quantity 3 minus 9. 2 times 6 times negative 6 gives me negative 72. And so my vertex is at the point 3 comma negative 72. So another way to talk about this is to go from actually having the vertex. So if I have my vertex, 3 comma negative 72, I know that my x-intercepts are always going to have a 0. So I know my x-intercepts are going to be in that form. So now the question becomes, well, what is the relationship between my vertex and my x-intercepts? Well, remember the vertex lies halfway between my x-intercepts. So what that means is that my vertex, h, is going to be, that my x-intercepts are going to be h some distance and h that same distance but in the opposite direction. So if you can imagine, I have my vertex here at h comma k, and I know that my x-intercepts are going to be some distance over in each direction, and that distance is going to be the same. So I'm going to have some distance h plus d and some distance h minus d, and because they're x-intercepts, they would be the y value would be 0.